Hello, everyone. So I am going to talk with you regarding using a formula and how to go about using a formula and give a couple of examples. So, so we're going to talk about using formulas. And by formulas, what I don't mean like formulas like baby formula, okay? What I mean is using math formulas, which are basically letter representations of where you would substitute numbers and do some math uh, operations to get an answer. So we use formulas for lots of things, like area. Area is a good example of a formula where we say A equals, now we're talking about just the area of say a rectangle. A equals length times width, right, is the formula for the area of a rectangle. And so if I had a length and a width, I could pop them in there and multiply, and I'd have the area. Or if I had the area and a length, I could do some algebra with that and get the width, right? So that's an example of a formula. Another example, so that's the area of a rectangle. The area of, say, a circle. Go back here. I want that to be correct. Of a circle is area, again, equals pi times radius squared. Pi times radius squared, that's a 2. Or we also say pi times, no, there's not another or, excuse me. We'll cut that part. All right, so that's the area of a circle, all right? And the area of a square is a type of rectangle, right? So we would find that area doing the same thing, but the area of square is A equals S squared. And we say it that way because all the sides are the same. So if I'm multiplying two numbers that are the same, what I'm really doing is I'm squaring that, right? Appropriately, that's the area of a square. It's being squared, right? Now, there's volume. There's volume formulas as well. And so if we wanted, let's say we had a cube. The volume of a cube is, and a cube has all the edges are the same length. All right, so it's side times side times side, or edge times edge times edge. And when we think about this, S equals side. What we really think here, if it was, say it was the area instead of a cube, it was a rectangle. All right, or what we might call it something else, but it's easier to say it's a rectangular cube. I'm going to say rectangular cube, right? I better not say it that way. So a cube has all the edges, all the sides are the same. But if we had, let's say I had something that didn't have all the sides that were the same, right, that look like this, okay, well, that is not a cube anymore, right? It's not a cube. We would call that we might call it a rectangular prism. Okay. Sometimes you might also hear it called a parallelepiped. Parallelepiped. Parallel. Piped. I'm going to figure out how to say that. Well, nevertheless, as you can tell, I always use the term rectangular prism. And a rectangular prism is the length times the width times the height. Okay. Now, look at this, though. So the area of a rectangle is length times width, and the area or the volume, okay, the volume of a prism is length times width times height. So they are related. So how do we use these formulas? Well, let's look at an example. And so let's say I have a prism. Let's say it's a storage tank. Okay. And the storage tank has a diameter of 50 centimeters. Okay. And it has a height of, so this is the diameter. It has a height of 80 centimeters. So this is the diameter, this is the height. Okay. And so what would I do with this? I would just take this information. I would figure out, first of all, how do I figure out what the volume of a cylinder is? Well, think about it. All right. If we use length times width for the area of a rectangle, and we use length times width times height for the area of or the volume of a rectangular prism, then we should be able to take the area of a circle, because what is a cylinder other than, right? It's got two circles, a circle on top, a circle on the bottom, that are the same size, right? So we should be able to take the area of a circle, pi r squared, and multiply that by the height to get the volume. Okay. And so I have the diameter. Now remember, I don't know, maybe you don't know this, but radius, 2 times the radius equals the diameter. Okay, 2 times the radius equals the diameter. So to get the radius of a circle, I just divide my diameter. So we can say it another way: diameter divided by 2 equals radius. Okay, and so that's the first thing I need to do. I need to take 50 divided by 2, and I get 25. So my radius is 25 centimeters. Okay, and so pi times 25 squared times the height, which is 80. Okay, and here, just get out your handy calculator. 25 squared is maybe, for a high school or college student, I would say you should know 25 squared is, but 25 squared is 625, right? So this is pi times 625 times 80. Now we're going to get a big number, right? Pi is 3.14 times 625 times 80. And this is 157,000, right, cubic centimeters. Cubic centimeters. And you pick centimeters because that's the unit of measure that was in the problem. Okay. So there's a couple of a good example of how to use area. That one's a little tricky just because you're given the diameter. You got to figure out what the radius is first, and remembering the diameter divided by 2 equals the radius, and then you can plug in your formula. You won't be expected to know these formulas necessarily. You'll be that information will be available, what the formulas are, on your test. Out of the way.